Now hopefully you've got your revision under control and you are making great progress towards paper 1. But if you're struggling to know where to start and need to maximise your maths in minimum time, then you should sign up for my rapid revision programme, Upgrade, as you can use it to build your very own personalised revision plan. Which means all you need to do is complete my revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but you can sign up for a free trial on my website now. And if you feel like you need top tier support direction from me, then sign up for my live weekly interactive lessons, which include revision specific lessons focusing on the topics that I expect to appear in exam papers 1, 2 and 3. Right now there is a special offer, and the next 20 people who sign up for live will get 100% free access to my upgrade programme as well, which means that you will have complete access to all the best resources that can help you achieve the grades you need to take you on to the next phase of your educational journey. Okay, so in this video we're going to be having a look at our first practice paper for the 2025 maths exams. We're going to be looking at a paper 1 non-calculator paper here for the foundation tier. Now remember, of course, this is just a practice paper and there's no guarantee that the exam's going to look anything like this, but it should give a good overview of a good selection of common topics for that paper 1 exam. But of course, make sure you look in the description to find some videos to get a full coverage of lots of different topics. Now you will be able to download this booklet in the description, and within the booklet there will be a QR code just here so you can get back to the video at any point once you've practiced the paper itself. Now we're going to get started with question 1 because we've got a lot of questions to get through. So this first question is asking us to write down the next number in the sequence. We can see here that it is going up in 6s each time, so adding 6 to that final number 20 gives us 26 for our next number in the sequence. Question 2 is about the order of operations, so we need to consider which operation needs to be done first here. Here it's multiplication, so I like to bucket off the multiplication. 2 times 5 is 10, so in fact this is 6 plus 10, which gives us the answer 16. Question 3 is a time conversion, so we're writing 2.5 hours in minutes. There are 60 minutes in each hour, so the 2 hours there is 120 minutes. The half an hour is 30 minutes, and if we add those together we get 150 minutes for our 2.5 hours. Question 4 is a bit of an awkward one to do on the screen, so of course if you have this printed out you just want to make sure that you are able to measure this with a ruler. Depending on how you have this printed out, whether it's A5 or A4, it's obviously going to come out at slightly different lengths, so you just need to make sure that you start your ruler measuring from 0 and you measure along to the end here. I've got a digital ruler that I can use and it comes out as 10.5, but that's probably going to be quite different to yours, so just make sure you double check you're able to measure with a ruler. Now question 5, it says a fair spinner has 8 equal sections numbered 1 to 8. The spinner is spun once. Write down the probability that the spinner lands on an even number. So between 1 and 8 there's 2, 4, 6 and 8. So there are 4 even numbers out of the 8 numbers that we have available, so our probability would be 4 out of 8. Now of course that fraction can be simplified, however it doesn't say it has to be written in its simplest form, so you're not going to gain additional marks for simplifying that down to 1 over 2, so I would just leave the answer as 4 over 8 rather than risk simplifying a fraction in a probability question and potentially getting the simplification wrong. So there we go, 4 over 8, or of course 1 over 2, or any other equivalent fraction to that. Question 6 is asking us to do an estimation. It says John buys 12.3 litres of paint and each litre costs £17.45. Work out an estimate for the cost of the paint that John buys. Now there are various answers that you can give to this. Now the easiest answer is to round each number to one significant figure, which is just one whole number and the rest becoming zeros. So 12.3 we would round to 10 litres, and £17.45 we would round to £20. Now, you could argue, of course, that different rounding would be absolutely fine. I'm sure it would be easy enough to do 10 times 17 instead, but we're going to get the full marks for using one significant figure, and 10 times 20 is a really nice quick calculation for us to do. We get a final answer of £200. Now, if you did do 10 times 17, you get £170. You could even do 12 times 17, which would give you another answer in between the two that we have looked at. But if you go for one of those answers, it's just going to take you a little bit more time. For example, if we do two significant figures, 12 times 17, we're going to need to probably set up a column multiplication, which of course is fine. It's not going to take too long to do. 2 times 7 is 14. 2 times 1 is 2, plus the 1 is 3, and then we've got to put our placeholder in, 1 times 7, 1 times 1, add it all up, and we get 204. So you can see it's super close to the original estimation that we've made anyway, so it doesn't really matter in regards to which answer we give here. The quickest, the easiest is one significant figure. 10 times 20 is £200. And there we go, we can give our answer as 200 or any of these other estimated answers along the way. Just make sure you show you're working out and you show how you've rounded the numbers. Okay, on to question 7, and we have a pictogram. It says write down the number of pictures sold in January. So it says in the key that the one square there represents 8 pictures, so we have 8, 16, 24, and I like to label that just at the end of the row, just in case I need it in a future question. And there we go, 24. Now it says 12 pictures were sold in April. Show this information on the pictogram. So the first square that we draw is going to represent 8, and we need an additional 4, which is going to be half of the picture. You can see that's been drawn in February and March as well, so we can replicate the image there. And there we go, that would represent 12. For part C, it says in May 40 pictures were sold. More pictures were sold in May than in March. Work out how many more pictures. So if we go to March, we can see that there are 8, 16 plus 4, that's 20 pictures, and it says that there were 40 sold in March, so 40 take away the 20 that were sold in March, sorry, we've got 40 in May, so 40 take away 20 is 20. And there we go, there's our final answer, 20 more pictures were sold. On to our next question, we have on the grid, draw an isosceles triangle. There are loads of different variations of triangles that we could draw here, and loads of different variations of isosceles triangles. The easiest way is to use an even number for the base, that way we can see exactly where the middle is, and then we just want to go up from the middle to any particular point. Let's go to here, and we want to join that up using a pencil and a ruler, and there we go, there is our isosceles triangle. Part B here, it says here is a solid shape, write down the mathematical name of this solid shape. Now, for this one here, we have a prism with a triangular face. So this one here is just called a triangular prism. And there we go, there is the mathematical name of that solid shape. Of course, just make sure that you know all your different solid shapes, such as a cylinder, and all of those different names for the fancy ones, like a cylinder, where it has a circular cross-section. Question 9 says Jane has a map. The map uses a scale of 1 centimetre to represent 4 kilometres. She draws a line between two towns that are 28 kilometres apart. Work out the length of the line she draws. So every little 1 centimetre on the map, let's imagine it's this big here, is going to represent 4 kilometres. And we're going to want to go all the way up to 28 kilometres. Now we could keep drawing this until we work our way up, but ultimately we just want to know how many of these 4s fit into 28. So 28 divided by 4 would give us 7 of those centimetre lines, so it would be 7 centimetres. Question 10 is asking us to write these numbers in order of size. Now at the moment we have fractions, decimals and percentages. We want them all in the same form. I tend to write them as decimals, but it's completely up to you. So I'm going to change them into decimals. 68% is our easiest one to do, so that'd be 0.68. The fractions, we're going to want them out of 10. So 3 over 5, if we times the top and bottom by 2, that gives us 6 out of 10, which is equal to 0.6 or 0.60, just to make it balance with all the others that have 2 decimal places at the moment. 2/3 is a lot trickier to write out of 10, but it is one that we should know. It's 0.6 recurring, and 0.6 recurring can also be written as 0.66 recurring. Now, got to be very careful if there's another decimal that's 0.66, because remembering there is another 6 after that 6 there, and lots of 6s after it, so we just need to be very careful just in case 0.66 is written, but of course it's not. So if we put these in order of size, we've got the 0.60, which is the 3/5. We have next the 0.62. Next we have this 0.66 recurring, or the 2/3. And then finally, we have the 68%. And also notice, of course, how I've written the original numbers back into the list. And there we go, that's ordering fractions, decimals, and percentages. So in this question, we have a conversion graph, and it says here, you can use the graph to change between centimetres and inches. So for part A, it asks us to change 74 centimetres to inches. So we want to find the centimetres, we want to check the scale. You can see here where around 74 is. Between the 60 and the 80, we've got 70 in the middle, and there are 5 squares between 70 and 80. So 10 divided by the 5 squares gives us 2 per square, so 74 would be 2 squares up, 72, 74, and we want to go across to our line, and then we want to very, very carefully trace down from the line. And we're going to read this number again, checking the scale, because this scale is slightly different. We've got 10 squares between 20 and 30, so each square is 1. So just before the 30 there is 29, so our final answer is 29. Change 40 inches into centimetres for part B. So we want to find 40 on the inches down here, and we're going to trace up to our line, being really, really careful, and then coming across. And again, remembering that scale there on the left, every square is 2, so that there is 102. And there we go, 102 for part B. Now, part C here does ask us to find 100 inches in centimetres, but you can see that our graph only goes up to 50. So we need to find a number that can be multiplied to become 100 relatively easily. Thankfully 50 does suit that. We could go for 10 or 20 though, but here if I go up and see where that 50 lands, which is just here, again we could argue potentially that's just slightly in between that box there, but if we go across, we'll read that very carefully, that's 122, 4, 6, 8. So I've got 128, potentially it's just slightly below, but 128 there for the 50 inches. So if 50 inches is equal to 128 centimetres, then we would times this by 2, and our 100 inches would be double the 128, which we could just do 2 in column addition. 8 and 8 is 16, 5 and 2. So 256 centimetres as our final answer. There we go. Now, of course, you could have used any amount of inches there that turns into 100. We could have gone for 10 or 20. You're going to have to scale it up slightly more, so do try and find the biggest number just to make it an easier calculation. But there we go, 256 for mine there, doubling the 128. Now for question 12, we've got some powers and roots and some fractions down there. For part 1, we have 4 to the power of 3, which is 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. And there we go, there's our first one, dealing with a power of 3. For part 2, we have a negative number being squared. And when you square a negative number, it's the same as squaring the positive version. So 5 times 5, which is 25. Just testing to make sure here that you know that a negative times a negative does equal that positive value. So 5 times 5 is 25. The cube root of 125 is asking what number times itself 3 times makes 125. The opposite of part 1 there, where we were cubing a number. The cube root of 64 is 4. The cube root of 125 is 5, as it's 5 times 5 times 5. Of course, if you don't know your cube numbers, you can always test a few out like this, and just until you get that match there. 5 times 5 times 5 is 125. And part 4 here, we are subtracting fractions. So we have 3 over 4, take away 2 over 5. We can make a common denominator of 20, which is just 4 times 5. And to do that, we times the left fraction by 5, the right fraction by 4. And that gives us 15 on the top of our left fraction and 8 on the top of our right fraction. 15 take away 8 is 7. So our final answer is 7 over 20. Question 13 here, we have a circle with a radius of 6 centimetres is enlarged. The radius of the enlarged circle is 18 centimetres. Find the scale factor of the enlargement. Just a 1 mark question here, just wants us to figure out how we get from 6 to 18. Now to get from 6 to 18, that is just timesing by 3. Of course you can do 18 divided by 6 to figure that out, and that means the scale factor is 3. On to question 14. We have a diagram in the shape of a cuboid showing a water tank, and it says the water tank is empty. It says Isabel wants to fill the tank with water. Water is sold in 500 litre bottles and a metre cubed is 1,000 litres. How many water bottles are needed to fill the tank? So this is about volume, and it's about the volume of this tank. Now, the volume of any prism, you work out the area of the cross section times it by the length. But a cuboid is the easiest one, as you take the 3 dimensions and you just multiply them together for the volume. So I want to look for the 2 easiest to multiply, as we do have some decimals here. 2 times 1.5 is nice and easy to start with. So 2 times 1.5 gives us 3. We can now multiply that by the final dimension, which is 0.6 in this case, and 3 times 0.6 is 1.8. 3 times 6 is 18, but it's 3 times 0.6, so it's 1.8. That is now a volume, which of course is in metre cubed. And it tells us here that 1 metre cubed is equal to 1,000 litres. So we can multiply this by 1,000, which will turn it into litres, and that gives us 1,800 litres. So we need to fill this tank. It's 1,800 litres, and it told us that water is sold in 500 litre bottles. So we could do one of 2 things. We could either do 1,800 divided by 500, which isn't the nicest without a calculator, or we could just count up in 500s. 500, 1,000, 1,500, which isn't enough, and then 2,000, which is enough. Of course, it's gone slightly over, but of course there we have 4 bottles as our final answer. So it says how many water bottles are needed? Well, we're going to need 4 bottles. So our answer is 4. And of course, just thinking about the concept here, you could do 1,800 divided by 500, but you are going to get a decimal there. So do think about counting up instead in questions like this, where you have to find this sort of capacity-based problem. And of course, remembering to round it to that sort of having enough. Okay, we can't say it's 3 point and then a decimal amount of bottles, because it says it's sold in 500 litre bottles. Okay, so there we go. A question looking at volume. Question 15 is looking at percentages. So part A says to work out 15% of 120. So a non-calculator method will first work out 10%, which is just dividing 120 by 10, which is 12. And then we'll also get the 5% here, which is half of the 10. So that is 6. And the combined total there is 18. So 15% is equal to 18. Part B asks us to write 90 as a percentage of 150. Whenever we are writing a percentage, we're going to first write it as a fraction. So this is 90 out of 150. Now we want that denominator to be out of 100 or out of 10, either is fine. But if we first have a look to see how this can simplify, we can divide them both by 3, and that will give us 30 out of 50. And that's going to be a nice one, because we can now make that out of 100 by multiplying by 2. So 30 becomes 60, and that would be 60%. You could have, of course, taken a slightly different route. We could have maybe divided by 10, which will give us 9 over 15. And then again, dividing by 3 would give us 3 over 5. and then 6 over 10, which again is 60%. So lots of different ways that you could find your way there. Completely up to you how you go for it. Question 16 is looking at a trapezium. There is a formula for the area of a trapezium, and that formula is that the area is equal to a half a plus b multiplied by the height. Now a and b are the two parallel sides on a trapezium. Here the parallel sides are the 10 and the 16, and the height is the 7. So the way I tend to write this is I'll first take those two parallel sides and add them together, and then divide that by 2, as it's a half of that. So that is equal to 26 divided by 2, which is 13. Now I want to multiply that by the height, which is 7. So we have to work out 13 times 7. And of course, without a calculator, I want to take my time to work that out. So 13 times 7, 7 times 3 is 21. 7 times 1 is 7, plus the 2 is 9. So 91 centimetres squared for the area of the trapezium. Be really careful, make sure you do check that dotted line. This one does have the units, centimetre squared, but if it doesn't, you're going to need to include those units as well. So just be very careful. Do make sure that you always look to see if the units are already included or not. And there we go, there is the area of a trapezium. Question 7 here is asking us to use a ruler and compass to construct the bisector of angle BAC. And you must show all your construction lines. Now again, a little bit of an awkward one because I can't use a compass here on the screen, but if we put our compass on point A, there are two ways of constructing an angle bisector. Now the way that I do it, I think it's the easiest way, is to draw one quick arc, then extend your compass and draw another arc. And then what you're going to do is something I just call a crisscross. We're going to join the bottom up to the top of this one, and we're going to join the bottom up to the top of the other two. Now they cross over at this point just here. So all we're going to do is join point A up to that point. You can extend it all the way through, and that's going to do an angle bisector for you. So there we go, that's one of your constructions. Of course, you need to know how to do a perpendicular bisector as well, but this angle bisector is a really, really nice one. So there we go, again, there we go. That was one of your constructions. Question 18 is asking us to round this number to two significant figures. So we want to find that second significant figure, which is the 7, and that's in the 10,000s position. So we're rounding this to the nearest 10,000. So it's either going to be 170,000 or 180,000. And this one is going to be 180,000 as there's an 8 after the 7. So that's going to go to 180,000, rounding to the nearest 10,000, which is where the second significant figure is in the number, the second number after the first whole number. And there we go, rounding to two significant figures. Okay, question 19 is looking at a better value question. So which offer is the better value? It says a shop sells compost in 20 litre bags and in 40 litre bags. One day the shop has two special offers for the compost. So we've got offer number 1, you get 20 litres, 2 bags for £3.50, or 40 litres, 3 bags for £9. Which offer is better value for money? So if we look at this first offer, 3 bags for £9, well, 3 bags would be 120 litres. As each bag is 40 litres, we're having 3 of them in the deal, and that is going to cost us £9. For the deal on the left here, 20 litres, we get 2 bags, so 2 of these for £3.50. So we get 40 litres for £3.50. So we want to know which is the better value. Now without a calculator, what we want is a comparable value. So we could either think about dividing to go down to maybe 10 litres or maybe down to 1 litre. Or we could multiply to make a lowest common multiple. So here, if we look at the larger one, 120, how many of these deals on the left would we need to buy to get 120 litres? Well, we'd need to get 3 of these to get a comparable amount. So if we times that by 3, we'd have 120 litres over here. And we're going to need to do £3.50 times 3, probably easier just to add together 3 of those relatively quickly. 0, 0, 0. 5, 5, 5 is 15. And then 369 plus the 1 is 10. So £10 and 50 pence. So £10.50. So the 120 litres on the deal on the left is going to cost me £10.50, but 120 litres on the right is only costing me £9, and therefore I would say over here the 40 litre bag is a better value. And we do need to write that conclusion there, backed up by proper working out, so make sure that your working out is super clear here, and it does give you a hint to do so, as it says you must show how you got your answer. So there we go, there is our best value question using multiples rather than dividing it down. Now of course, if the numbers were relatively nice, if it was 4 litres and 2 litres, they would have been relatively nice to divide by 2 and divide by 4 to sort of see the better value for a smaller amount. But if not, don't forget you can take this approach as well, finding that lowest common multiple of the 2 amounts that you're looking at. And looking at our next question, we have express 84 as a product of prime factors. So really, really important here that we get the first 2 correct, because that's where we're getting our first mark. And if we get that wrong, we're getting the rest of it wrong. So we want to be really, really careful. It's an even number, so let's just divide it by 2. Half of 84 is 42, and there we go, that gets our first part of our prime factor tree correct. 2 is a prime number, 42 is not, so 2 and 21. There we go, again, 2 is prime. We can no longer divide by 2, but 21 divides by 3, so that'd be 3 and 7. And there we go, there are our product of prime factors. There are 2 ways of writing our answer here. We can write it as 2 times 2 times 3 times 7. Or, because there are 2 2's, I can put 2 to the power of 2 times 3 times 7. Either answer there is absolutely fine. You don't have to put the powers in unless it's specifically said you need to write your answer with powers. Otherwise, there is our final answer, 2 squared times 3 times 7. Okay, our next question is dividing decimals. So it says work out 47.85 divided by 1.5 and give your answer as a decimal. Now when we're doing this, I would take the approach of removing the decimals and doing some bus stop division. So let's do 4,785 divide by 15. And if we do that and we set up bus stop division, 15 into 4,785, probably want to write out a couple of multiples of 15. So 15, 30, 45, 60. I'll write out more if I need to. 15 goes into 47 3 times, up to 45. So carry over the 2. 15 goes into 28 once, as we don't quite get to 30 there. That gives us a remainder of 13, and then we're going into 135. So I need to write out a few more of these. So 75, then 90, then 105, 120, and 135. There we go, it meets it perfectly. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So 319 would be my final answer there. Now to figure out where the decimal goes, what I'm going to do is I'm actually going to use a process we used earlier, and that's to estimate this calculation. So if I estimate this calculation, that would be 50 divided by 2, which is 25, which is going to help me figure out in terms of place value exactly where that decimal goes. So it's got to be close to 25. So instead of 319, it's going to be 31.9. There we go, it's in that tens sort of value there, 31.9. And there we go, there's my answer, 31.9. And there we go, there is dividing decimals. Okay, so our next question is looking at fractions, percentages, and ratios. So it says Emily has 360 flowers. The flowers are lilies, tulips, daffodils, or roses. 3/8 of the 360 flowers are lilies, 35% of the 360 flowers are tulips, and the number of daffodils to the number of roses is in the ratio 4:5. Work out the number of roses Emily has. So to start with, we want to go for this first piece of information here, which is that 3/8 of the 360 flowers are lilies. Now we've got quite a lot of flowers here, so all the numbers are going to be relatively high. We're going to have to do quite a bit of division and bits here. So let's just start working out the fraction of the amount. So 1/8 is going to be dividing by 8. So we are going to want to go for 360 divided by 8. 8 goes into 36. 8, 16, 24, 32, so 4 times with a remainder of 4. And then it goes into 40 5 times. So 1/8 is equal to 45. 3/8 will be 45 times 3. Take our time to work that out. 40 times 3 is 120, plus the 15, so that is going to be 135. So there's 135 lilies. The next thing to work out is this 35% of the 365, or the 360 flowers, are tulips. So if we work out 10% to start with, 10% is equal to 36, and 5% is going to be half of that, which is 18. So we want 3 of the 10s, which give us 30% plus the 5. So we want 3 36s and an 18. I'm just going to use column addition to add these up. That shouldn't take too long. 6, 12, 18 plus the 8. 18 plus 8 is 26. So 26. 3, 6, 9, 10 plus the 2 is 12. So 126. There we go. So 126 of the flowers are tulips, and the remaining flowers, the roses and daffodils, or the daffodils and roses, are in the ratio 4:5. So if we add these two together, let's see how many lilies and tulips that we have. So 135 plus 126. Just realised we put a 6 there. Let's change that. 135, 126. That's 11. 3, 4, 5, 6. 261 out of the 360. So we have 360, take away 261. I can actually see there that that's 99. Obviously take your time to do your subtraction there, but that comes out as 99. So there are 99 flowers that are left over, and they are in the ratio 4:5. So I need to split 99 in the ratio 4:5. So 4 plus 5 is 9 parts. 99 divided by 9 is equal to 11, and then we have daffodils to roses in the ratio 4:5. We want to multiply both of these by 11, and that's 44 to 55. We want to work out the number of roses that Emily has. Roses is the 5, which is the 55. And there we go, we have 55 roses. So a big question there, we've got fractions of an amount, we had percentage of an amount, finding what was left and sharing that in a ratio. So you've got to know all of those processes really, really well to tackle a question like this. So just make sure that you're super confident with all those little different processes within that question. And there we go, our final answer was 55, and we get a lot of marks for a question like that. Okay, our next question is looking at a scatter graph. It says the scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. It says one of the points is an outlier. Write down the coordinates of this point. So an outlier is a point which lies quite a distance away from the line of best fit. So if we draw a line of best fit, which goes somewhere like this through the points, and you can see over here we have this one point over here which is out of the way. It doesn't follow the rest of the points. So the coordinates of that, let's have a look. We'd obviously just want to trace down, read that carefully. There we go, so that's on 10, and across here it's on 19. So the coordinates of that would be 10, 19. For part B, it says describe the relationship between the maximum temperature and the number of hours of sunshine each day. So if we are describing a relationship, that's different to describing the correlation. So if we're asked to describe the correlation, well, this has a positive correlation as it's sloping up, but this is asking us to describe the relationship. So when we are describing the relationship, we're going to use the key terms that are written on the axes here. So we have the number of hours of sunshine and the maximum temperature. So we're going to try and use a logical explanation here, which would be as the number of hours of sunshine increases, the maximum temperature increases. Or on days where there are more hours of sunshine, the temperature is higher. Anything along those lines. I'm not going to write one down because there are different ways that we could explain this. We could also change that to the opposite. On the days where there are less number of hours of sunshine, the maximum temperature is lower. So I would tend to say as one of these is increasing, so is the other. Or if the graph had a negative correlation, we'd say as one increasing, the other was going down. This has a positive correlation, so we're going to use the language on the axes. As the number of hours of sunshine increases, the maximum temperature increases. And there we go. So that would be a description for the relationship. For part C, it says, on the same day in another town, the maximum temperature was 17.6. Estimate the number of hours of sunshine. So we're going to go to 17.6 on our maximum temperature, being careful again of the scale. So this is 17 here. Each square is 2, so 17.2, 0.4, 0.6. We're going to go across really carefully. Hit our line of best fit. Of course, yours might be slightly different to this, so yours can be different to my answer. There's a little bit of leeway either side. There we go, that's just before the 14, so that's 13.8 on mine. So 13.8 would be my answer, 13.8 hours. And again, just reading that very carefully from your line of best fit, yours might land on a slightly different number, maybe yours lands on 14 or maybe it lands on 13.6. Again, they would be fine. Important part there is to use your line of best fit and show how you've used your line of best fit. So trace that line across and show where you've met the point. But there we go, that is using a scatter graph. Question 24, we have some probability from a table. It says a bag contains blue, green, red and yellow marbles. A marble is going to be taken at random from the bag and the table gives information about the probability of taking each colour of marble. Some of them are given to us in terms of algebra and it says find the value of x. So these numbers in the table have to add up to 1. At the moment, we've got these two here, which add up to 0.52, which means what's left over has to add up to 0. I'm just going to do 100 take away 52, which is 48, so 0.48. And it's worth writing that working out down. 1 minus 0.52 is equal to 0.48. Now this is given to us in terms of algebra. Now what we can see here is that this is 2x and this is 1x. So it could have given this us in language. It could have said red is twice the probability of yellow, and that's what that means, 2x and 1x. Red is twice the probability of yellow. So if one's twice the probability of the other, you could write the algebra in yourself. We could write this as a ratio, 2 to 1, but ultimately we want to divide this 48, what's left, by 3. Now I prefer personally to just divide the whole number, so 48, imagining it's just a percentage instead, 48% divided by 3, 3 goes into 4 once, remainder 1 goes into 18 6 times, so that would be 0.16. So x is equal to 0.16. It doesn't ask us to fill it in, but that means this would be 0.32 and this is 0.16. Only asks us to find the value of x, so 0.16 is our answer. In part B it says if there are 64 blue marbles, work out the total number of marbles in the bag. Now this is a reverse percentage question essentially, or a reverse decimal if we choose to keep it as a decimal, but this is referring to the blue up here, which is 0.32. So I would just write that 32% is equal to 64 marbles. Okay, all I've done is written that decimal as a percentage. Makes it a little bit easier for now for me to figure out what 100% is, because I'm going to have to get to 100% and I need to think what can I divide both of these by to go down to a slightly smaller number, because we can't go from 32 straight to 100. Now thankfully they both divide by 32, so it's actually a relatively nice one. If we divide by 32 we get 1% is equal to 2 marbles, and now I can times by 100, and 2 times 100 is, of course, 200 marbles. So there we go, we have 200 marbles as our final answer, 200. So a bit of a reverse percentage there within the probability from a table question, which is always quite a tricky variation, quite a tricky question in terms of this topic there, but there we go, 200 marbles is our final answer. Okay, question 25 is looking at what looks like a lowest common multiple question, but let's have a look. It says 2 alarms ring at 6 a.m. One rings every 18 minutes, the other rings every Z minutes. So it's not told us what the other one rings by. They next ring together at 7:12 a.m. Find the smallest possible value of Z. So we're trying to find out exactly when they next ring, which is at 7:12, but we want to know exactly how many minutes the other one must have done if that's the next time they ring together. So for example, if the other one rang every 2 minutes, well, they might not ring again at 7:12 because 2 at 18, you would expect them to ring at 18 minutes later, which would be 6:18. So we need to find out what this number is going to be. So first, let's figure out exactly how many minutes it is from 6 to 7:12. Now that is 1 hour and 12 minutes. So 1 hour and 12 minutes, that's 60 minutes, plus 12, which is 72. So we're looking for two numbers that have a lowest common multiple of 72. Now 72 can only be divided by certain numbers. So if we find the factors of 72, then we'll have an idea of what those numbers could potentially be. So let's find these factor pairs. So 72, we can have 1 and 72. We could have 2 and 36. 3 goes into 72. How many times? Let's just check. 3 into 72. 3 goes in twice, remainder 1, 4. So 24 times. Does 4 go into 72? Well, it has to. That 2 goes in, and we can halve the 36. So 4 and 18. 5 doesn't go in. 6 does go in. It goes into 60 10 times. It's an extra 2 there. So 6 times 12. 7 doesn't go in, 8 goes in 9 times. Okay, so we have a very big factor list here for this 72 minutes. So what I want to do is I want to work through, and again it wants me to find the smallest possible value of Z. So there's no point in starting on 36 or 24 or the larger numbers. I want to start on the smaller numbers. So what I'm going to do is I'm going to start with the smallest number. I'm just going to think to myself, are they going to ring again before 7:12? And if they do, I'll cross them out. So if it was every 1 minute that the other alarm went off, then they would, of course, ring after 18 minutes together. So it's not 1. 2 would also ring after 18 minutes. So it's not that one. 3 would also ring after 18 minutes because that goes into 18. 4 is the first one that we're going to have to test. So let's think. 4. Well, 18 is going to ring at 18 minutes. It's going to ring at 36 minutes. It's going to ring after another 18 minutes and then at 72. So 36 add 18, what's that? So 46 plus 8 is 54, and then it's going to ring at 72. So does 4 minutes ring at any of these points? It doesn't ring at 18 because it doesn't meet 18. It goes 16, 20, but it does ring after 36 minutes, so it's not the 4. 6 is also going to ring at 18 and at 36 and at 54, so it's not 6. 8, let's have a think, does 8 go into any of these? 8, 16, 24, 32, 40, 48, 56. So it does miss them all, and then it rings at 72. So 8 is the smallest it could be, because that would also only ring at the same time as the 18-minute alarm after 72 minutes, as it doesn't go into 18, 36, 54, but it does go into 72. So there we go, the smallest possible value would be 8. Now that's a very difficult question there because we were looking at basically multiples, but we didn't know what one of them was. So that's quite a tricky sort of reverse lowest common multiple question. But there we go, looking at factors that went into the total and then testing however you wanted to test them. I sort of just did them in my head and said them out loud, which ones would meet at 72 rather than the other multiples of 18 that we tested there, 18, 36, 54 and 72. There we go, quite a tricky question that one, but there we go, a little strategy for you for answering a slightly trickier variation of a question like that. Okay, question 26 is an inequality on a number line. It says write down the inequality. So when we are writing an inequality like this, that's not a joint inequality, so not one where there are two lines drawn together like this. That would be a slightly different variation. So this one that we have here, we have x is going to be, and then we're going to say bigger than or less than. So the actual arrow is the same way that this arrow is pointing here, so greater than. And we're just going to write the number that it's next to, -1. And there we go, there's our inequality. Now that's going to change if this circle was coloured in and there was extra ink in the circle. We'd have extra ink on our inequality like that. But of course it's not coloured in, so we're not going to put that extra line in as it's not been coloured in. Obviously you can have a different variation like I drew a second ago where it's between two numbers. Let's just make a really small one here like that, and that's where x goes in the middle, both arrows point to the left, both these numbers are on either side, and then again if one of them's coloured in we have the extra line in, but a different type of inequality on a number line there. But this one, just a straight inequality, x is greater than -1. Part B here is solving an inequality. So here we want to look for the smallest unknown as they're on both sides. The smallest is this -2n. So we want to get rid of that by adding 2n to both sides. If we add 2n to both sides, we have 12 plus 6n is greater than 50. We then want to get rid of the numbers as we have the n's together on the left now. So minus the 12. And if we minus 12, we get 6n is greater than, and that goes to 38. And then we want to divide by 6. And if we divide by 6, 38 doesn't divide perfectly by 6. So we could write it as 38 over 6. Now at this point, you might feel like you've done something wrong. But if you're confident that you've done your equation correctly here, that's absolutely fine for an answer to come out like that. Now we can actually just leave the answer as that fraction. It doesn't say anywhere here that anything needs to be written in its simplest form or anything like that. You could, of course, simplify this. We could divide them both by 2. 38 divided by 2 is 19. So you get 19 over 3. Or any other variation. If you want to sort of write that as a mixed number or anything along those lines, you could do as well. I wouldn't advise trying to convert it to a recurring decimal or anything like that as it's in thirds. But there we go. Answers can come out as decimals, they can come out as fractions, and that's absolutely fine, and it's nothing to worry about, particularly this later on in the paper. The next question is looking at pressure, force and area. It says a solid cube is placed on a horizontal floor. The cube exerts a force of 150 newtons on the floor. The pressure on the floor due to the cube is 6 newtons per centimetre squared. Work out the volume of the cube. Right, not the nicest because it's looking at the volume of a cube. Now the formula up there, we are given 2 of the pieces. So we are told the cube exerts a force of 150. We don't know the area, but we do know that the pressure is 6. So let's have the area as x, and that's the unknown for the moment. So we can work out this unknown. We just need to figure out what you divide 150 by. That gives you the answer 6. And we can obviously swap that around. I think we can just do 150 divided by 6 to figure out what that number is. So if I do 150 divided by 6, 6 goes into 15 twice, remainder 3. And then 5 times into 30. So that would be 150 divided by 25. That would give me the answer 6. So the area is equal to 25. Now a cube, all of the faces have the same area. That's what makes a cube special. All the faces have the same area, all the sides have the same length. So we have a cube here that has an area of 25 centimetres squared on all the faces, of course, including the base. Now to work out the volume of a cube, we need to know what all of these side lengths are. What's this one? What's this one? And what's this one? So we're almost thinking about the reverse area of a square. Now if a square has an area of 25, then the side lengths would be the square root of 25, which is equal to 5. So each of the sides would be 5, and that would give us the area 25 centimetres squared. You don't necessarily need to think about the square root there, it's just a logical question. What are the 2 same numbers that times to make 25? Now that means all the side lengths of the cube are all 5. So to work out the volume of the cube, we would do 5 times 5 times 5, and 5 times 5 times 5 is 125 centimetres cubed. And there we go, there's our final answer, 125 centimetre cubed. Quite a tricky question there, because you've got a rearrangement of the pressure formula to work out what the area was, and then that was leading into sort of reverse volume of a cube there, giving you the area of the face and working backwards to find the side length of the cube. So definitely a tricky question, definitely one to be having a good think of there in regards to sort of area and volume. And on to question 28, it says here, complete the table of values for y equals 6 over x. And it wants us to draw that graph and then use it to figure out an answer down the bottom. So let's have a look. Complete the table of values for y equals 6 divided by x. And we've got all these different numbers to divide 6 by. So starting from the right hand side, because 6 divided by 6 is 1. So that's a dead nice one. In the middle, you've got 6 divided by 3. That's 2. That's a nice one as well. And the rest there are going to take us a little bit of time to work out. So onto the left, all the rest aren't the nicest, so we're going to have to sort of pick one to start with now. But 6 divided by 0.5, when you divide by a half, it doubles the answer. It goes in twice as many times. So 6 divided by a half is 12. Now, if you don't like that concept, you can write it as 6 over 0.5 and then make the denominator equal 1, so times it by 2, and that would give you 12 over 1, which is 12. So that's another way that you could look at it as well. 6 divided by 1.5 might just be easier to figure out how many 1.5s go in. So 1.5, another 1.5 is 3, and then 4.5, and then 6. So that goes in 4 times. And the final one is this 6 over 5. Not the nicest there. Again, I'm going to write it as a fraction, 6 divided by 5. And I think possibly the easiest way to do this would be to make that out of 10. So that would be 12 over 10, which is 1.2. I mean, that one there is actually pretty tricky. So that's quite a tricky concept to apply on this sort of non-calculator style question. But there we go, a little thought process for you. If you have to do something like that, a nice easy way of turning it into a decimal would be to make it over 10, so 1.2. Right, we've got to plot these points. So we've got 0.5 goes up to 12. Let's have a look. 0.5 is that first line. So up to 12, that's going to be just here. We have 1 that goes up to 6. So that's going to be just here. 1.5 goes up to 4. And that is there. 2 up to 3 and 3 up to 2. So 2 up to 3. 3 up to 2. And then we've got a couple left. 4 up to 1.5, up to 1.5, that's in the middle there. 5 went up to 1.2, which is about here, and 6 went up to 1. There we go. And notice how I didn't overly stress there about the 1.2. I've just gone just above the 1 square up, that's 1.2. Seems okay. I'm not stressing too much about that square or that cross that I've done being absolutely perfect. I'm just drawing it as best as I can. So I need to join this up. It does make a nice smooth curve. It's not the easiest for me to join up as we have to scroll as we do it. But coming down there, we get a nice smooth curve that goes through all those points. And there we go. And that is the positive region of a reciprocal graph. So there we go. That is the graph drawn. It says here, use your graph to work out the value of x when y equals 5. So when y equals 5, that is up here on the y-axis, in between the 6 and the 4. That's where y equals 5 is. So work out the value of x when y equals 5. Well, if we go across to our graph, it meets it just there. And if we come down, there we go. We can read that point. There's 10 squares between 1 and 2, so each one's 0.1. So that's 1.1, 0.2. So 1.2 is our final answer there. X would be equal to 1.2. And there we go. That's our final question. And that is the end of this paper, looking at this paper 1 practice paper for the foundation exam. Now, of course, remember, there are a lot of topics that can come up, and I'll link in the description a video which covers a lot more topics than this, but hopefully that is a good practice paper for you for this first paper, for this first exam. So do keep an eye out in the description for any of the upcoming videos. Obviously, watch out on the channel for any new upcoming videos for the next papers as well. There will be papers getting released that cover topics that don't appear in paper 1, but otherwise do make sure you check out the rest of those videos, and I will see you for our next video for our next paper. One of the most common requests I get from students is for specific advice on how to revise for exams. So today's video covers my 5 top tips for GCSE maths exams. Tip 1. My grade calculator. Go to my website and complete my grade calculator to get your estimated working at grade, so you can get an idea of your starting point. You'll be able to answer common exam style questions from either of the exam tiers for higher or foundation, and once you've completed that you will receive a report which gives you that estimated working at grade, so you can start to look at your next steps. Tip 2. My ultimate revision guide. Go to my website and request all of my free resources. Then once you receive the email, download the attachment and complete my ultimate revision guide so you can practice every single topic that can appear on the exams and make sure that you know exactly what to do next. Tip 3. My revision checklist. Once you've completed my ultimate revision guide, use my revision checklist to identify the topics that you need to prioritise, so that you can work through those specific video lessons available for free on my YouTube channel. Tip 4. My practice papers and booklets. Once you've worked through the YouTube lessons, then you need to work through the practice papers and booklets to solidify your understanding in preparation for the exams. You can download these from the website, and there are video solutions to accompany each booklet. Tip 5. My rapid revision system. Alternatively, if you need a time-efficient approach due to the other subjects that you need to revise for, then you should sign up for my rapid revision program Upgrade, as it combines all of the benefits of the 4 previous points but turns them into a personalised revision plan, which means all you need to do is complete my revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid program, but you can sign up for a free trial on my website now. And if you feel like you need top tier support direction from me, then sign up for my live weekly interactive lessons, which include revision specific lessons focusing on the topics that I expect to appear in exam papers 1, 2 and 3. Right now there is a special offer, and the next 20 people who sign up for live will get 100% free access to my upgrade program as well, which means that you will have complete access to all the best resources that can help you achieve the grades you need to take you onto the next phase of your educational journey.